Let's continue with learning how to determine the order of reaction involving single reactant. There are few ways that you can use to determine the order of reaction. And then for our syllabus, we only focus on 0, first and second order of reaction. Okay, now, and remember, we only focus on single reactant. So we shall learn the initial rate method. Okay, for this initial rate method, usually it refers to table where we compare the rate of different experiment. Now let's look at, usually initial rate method must provide table. Okay, then let's look at what we have here. Okay, first, order of reaction. Determine the order of reaction with respect to each reactant and overall reaction order. Alright, remember the order of reaction do not refer to the coefficient. Now, what do we have? We have nitrogen monoxide and chlorine. Okay, so we want to write down the rate law, but of course we don't know the order, so we put M and N first. So this is the order of reaction for each reactant. Overall, we use M plus N. So first step, always write the rate law. Okay, the M and N, you can use any alphabet that you like. Okay, and must write with this. Most students, they left out this step because this step 1 mark. Then after that, you find the reactant which has constant concentration. Okay, for example, 0.125, 0.125. Okay, why? Because we can find the other order of reaction that has changes. Okay, for example, now we find out that, okay, we compare 2 to 1, rates of experiment 2 to 1. And then after you cancel, because why we choose the same? Because we want to cancel out the same concentration and we will only focus on one order only. Okay, so then we can get N equals to 1. Okay, then thus the order of reaction with respect to chlorine must mention, is it chlorine or nitrogen monoxide, equals to 1. And then must write the sentence. Most students just write N equals to 1 and then they left out the sentence. Okay, now another question. Determine the order of reaction is the same to each reactant. Just now we have find chlorine. Now we continue with nitrogen monoxide. Okay, so same thing, if you want to find nitrogen monoxide, then you want to cancel the chlorine part. So this time we compare experiment 3 to experiment 1. So we can cancel the chlorine one. Okay, after that you will get M equals to 2. But what does M equals to 2 means? M is the order of reaction with respect to nitrogen monoxide. Okay, remember to write the order of reaction. And don't forget, we need to find the overall reaction order. So overall reaction order just now, chlorine is 1. Nitrogen monoxide is 2. So 1 plus 2, M plus N, we get 3. Okay, now next one, write the rate law. Okay, write the rate law is easy. We have found what is the order of reaction for nitrogen monoxide and chlorine. So we just substitute. Okay, as usual, 1 we do not write down in the rate law. Okay, now another one which is more difficult for students because most students having problem to find the correct unit. Okay, to find the rate constant, since we already know the rate law, we also know the rate, you can choose any experiment data. It can be experiment 1, 2, or 3, but I choose number 1, for example. So remember, the unit is important when you want to look for rate constant. So rate is molar per second given. And then remember, we have concentration, so it is molar. Okay, so after that, when you solve the problem, you will get the final unit for rate constant, which is compulsory. Okay, but student having problem, how to solve this problem to find the unit of rate constant? Okay, I would do one by one in calculation. For example, to find K, I rearrange, then I will get M molar per second, then this one molar square, then this one is just molar. Then I cancel out, I will get the rate constant unit. It's not that difficult, just take some time only. Okay, another one we can find initial rate. Okay, for any of the experiment. Okay, for example, in this table, it is given for chlorine. Okay, so how do you find it? We've already find rate constant. Rate constant is the same for all experiment at same temperature. So you substitute the rate constant, then you have nitrogen monoxide. Oh, sorry, this now should be number 5. I look at number 4. Okay. Okay, so here is the initial rate. Okay, and then we have nitrogen monoxide and chlorine. Okay, so we can find the answer, and remember the rate is molar per second as stated in the table. Okay, another one, we also can calculate the initial concentration. For example, X. Okay, it's the same thing. Look at experiment number 4. Substitute all the information, and remember X is the concentration, so it must have unit. Now, points to remember. For initial rate method, always begin with rate law. You can write MNP, you can write XYZ, up to you. Okay, then after finding the order of reaction for a single reactant, remember to write the sentence, that is order of reaction with respect to reactant is, okay, how much from your calculation. And then remember rate constant is K, it must have unit. Okay, then remember you have different terms, you must have different unit. For example, rate is concentration over time, but time can be second, minute or hour. Refer to the table. Concentration is, we use molarity, and then rate constant unit must calculate. Okay, so that's all for initial rate method part.